In this seminar, we'll explore the use of feature-based machining in NX-CAM version 9. This is also known as FBM. In the past, FBM could be difficult to implement because it required the machining knowledge editor, which is based on a custom programming language. We still use the MKE in our work for FBM. However, Siemens has created a couple of new commands that can help us get started with FBM. They're teach feature and teach operation. And when we use these commands in the NX interface, we're actually writing to the machine knowledge editor. So this allows us to get started with FBM and create fairly complex rules for identifying features and machining them without knowing that custom language. So let's get started with the file that we see on the screen. It's a mold component. This file already has a tool residing in it. This tool did come from the tool library, and this is very important because we want to be able to use our machining knowledge in other files. If the tool resided only locally, there would be no real way for those other NX files to be able to access it. So when you get started with the teach feature and teach operation commands, make sure you're using tools that come from the library. We'll switch over to the geometry view, and the only thing I've really done here is just define the workpiece as that part. Next, let's switch to the machining feature navigator. That's the next tab down from the operation navigator, and the feature that we want to teach is this oval slot here on this side of our part. I'll select teach features from the right click menu, and I'll select a place for this to go. I'll put it in my customer feature area here, and I'll hit add new feature type, and I'll call this slot 1. Then while that's highlighted, I'll come down to the recognition rule area, and again this must be highlighted. I'll hit add new rule, and then it links up the recognition rule to the feature type. We'll get to these other options here in a few minutes. The next thing I must do is select the faces that make up the feature I want to identify. So I'll move into the graphics window, select the floor, and I'm on tangent faces for my filter. So here I can just select one face and it chains around. Then I hit the teach recognition rule, and it does give me a warning that says there's something similar out there already. That's fine though, it's not necessarily a problem. And then we click OK. You see a little delay as it's actually writing that information out to the machining knowledge editor. Now let's test our ability to recognize that feature. Using the right click menu again, and here we select find. We'll choose parametric recognition, and the geometry is our workpiece. Recall that we named that feature slot 1, so that's the only one that's checked here. I know it's hard to see this entire list, but there are many types of features that already exist in the machining knowledge editor, and it's showing us a list of those, so we can use the checkboxes to determine which features we'd like to recognize. If we wanted, we could assign a machining access direction. We'll leave that at none to, in other words, select features on any access direction. I select find features, and as we expect, it recognizes a slot 1 and highlights in red that area. That shows up here then as a recognized feature in our list. Let's move back to the operation navigator. We'd like to create an actual operation and then assign that operation to that slot geometry. let's use our floor wall machining. It picks up our tool, and we'll use a mill finish method. I'll select the floor and a follow part cut pattern. So here's our operation. Next, I'll right click on the completed operation, and under Object I'll choose Teach Operations. Here we need to decide where in the library we're going to put this. There are many headings already here, but we'll put it in example mill colors. It doesn't really matter where we put it, just so we kind of remember where that's at. Then we select the feature that we want to machine. It highlights in orange. Finally, at the bottom, create machining roles. Okay, next we're going to open a different file and see if our teach operation and teach feature is working correctly. Here's the file we'll use to do our testing. It has more slots plus some slots that are somewhat different, and we want to make sure that our operation identification, or I'm sorry, our feature identification doesn't get confused by geometry that doesn't really match. Also, we've got a slot off at an oblique angle. Here in the Operation Navigator, we'll start at the geometry view. Our MCS is in the middle of the hole. I do need to define the workpiece. And because we have this slot at an oblique angle, for the feature-based machining to work, we need to make a change to the MCS mill object. It does not reference anything about an off-axis orientation for our features. Here's how we take care of that. I'll choose Object Customize from the right-click menu, and the tool axis can then be added to the dialog. So now when I double-click, you see that I can select all axes for my orientation. This will allow features from any orientation to be identified and machined. As we look at the Create Geometry menu, this will need to occur for any MCS that you grab from Mill Planer or Mill Contour, but if you get your MCS from the hole making dialog, you'll find that it already has that option customized in the menu for the MCS, so you won't have to add it separately. Okay, let's begin then by identifying features. We'll right-click to choose Find Features like we did before. We've got our workpiece selected, so it highlights green. And in the sample color features, slot 1 is selected. By selecting None for the machining access direction, it should successfully identify features at any orientation. Now I'm running off the bottom of the video again, but here's the Find Features button. So let's look at the features it identified and the ones it left out. It didn't find anything here in the middle because that doesn't match the geometry. This is an oval slot, but it's rounded on the edges, so that's not going to identify. And then this one is not an oval slot. So it did correctly pick out the correct geometry. So we'll click OK. And then these are all added to the Machining Feature Navigator. If you select them individually, you can see them highlight. Next, let's test our ability to create operations. So we'll right-click on those selected features and hit Create Feature Process. And remember that we put our feature down here in example mill colors, so that is the library that we need to have selected at this time. It is important to have your workpiece defined and have it selected here. Otherwise you'll get a failure. Okay, we don't see anything different in the Machining Feature Navigator, but let's go back to our Operation Navigator, and now we see that we have two groups. We'll generate on slot 1, and that looks correct. And because the other slot's at another orientation, it creates that as a separate geometry group. And that also appears correct. Now let's add more capability to our ability to process and identify these features. Here we'd like to identify features only of a certain color. So if we had parts where some of them were perhaps requiring a higher tolerance or something, we could color those, and if that was part of our process, we could identify those particular features separately. So I've already got this one colored as strong azure. Let's go ahead and show you how to teach that feature and put the color identification into that definition. Everything's going to start as it did before. We'll add feature type and call this slot color. Again, we'll add it to the sample color features and choose add new role. Before we continue though, in this area we'll check the box for face colors. The next part is just as we did previously. We select the faces that make up that feature and hit Teach Recognition Role. Okay, that slot color definition has now been added. We'll return to this part, and now I've colored 2 of the slots but not the rest. Here we want to find features. And we must be careful to only identify the slot color types. And even though previously it was also identifying this slot and this slot, because of the color requirement, it only picks the 2 on the end. So that's a correct solution. We could continue now and machine those features. Now we'll look at another addition to our ability to filter while we're identifying features. In this case, our intent is to use our slot identification technique, but limit it to slots that are 60 millimeters wide or wider. We'll do this by first applying a PMI dimension to identify that width. So I'm here in the PMI section and I've just chosen the rapid dimension. Now it's very important when you place this dimension that it must be pointing at elements that are part of the feature you'll eventually be identifying. So there's my dimension, and it's currently 65 millimeters. Before I can continue with this though, I need to add something to the dimension. So I double click on it here, and the text I'm going to add must occur to the right. So you can't put it in as a prefix. It's got to go right here as a postfix to the dimension. And I'm going to name this width. It must be capital letters. I do a space and a greater than symbol and then 65. When I close then, I see that postfix after my dimension numerical value. Okay, now we're back to the Machining Feature Navigator. I will right click and Teach Feature, so this starts just like before. I'll name this slot width. And we'll put it again in the sample color features. Okay, it's very important then to check the PMI annotations to make sure that that PMI dimension gets saved with our definition. Then we select the faces again and teach the recognition role. Let's test this on our other part. We'll choose Find Features. And slot width is the one we're looking for. And it's hard to see, but here at the bottom is Find Features. So this time it found 3, and it ignored this one, which it had been previously selecting. Remember, our dimension here was 60 millimeters. Let's just double check with a quick measurement. And that's 58, so that's less than 60. That's why it didn't select that slot. So that's a significant capability, because as you see, we did not have to add PMI dimensions to each one of these slots for it to work. We only added the PMI dimension to the seed file where we were creating the definition. The machining knowledge editor and the feature-based machining algorithms are smart enough, once they've been taught, to recognize that width dimension when it identifies a feature. When we're machining complex features that have multiple operations, we sometimes need to be able to identify different areas of our feature. NX9 can now do this with the feature-based machining algorithms using the PMI. So I'll start this part of the lab here in PMI, and I'm going to create a note. I've already got the text filled out. What I'm going to be doing is tagging this face as the floor. So I'll select that as the object. That's very important that it makes the association between the word floor and that face. Then I need to specify a location for the PMI itself. And I'll just place it out here in space. I think you can see that. And then we close. Next, just to double check, when I'm in the part navigator, I can in fact verify that I've got that PMI note, the word floor, and the associated face. Okay, back to the machining feature navigator. We'll right click and teach features. And here we'll call this slot floor def. We'll put our recognition role in the sample color features again. And note that I don't have to check the PMI annotations here. We'll teach the recognition role. Okay, back to our other part. Before I begin, I must delete the other definitions. And now let's find features. Here's our slot floor depth. But on this one, I'm also going to select the steps. And this is the out-of-the-box feature-based machining for holes. So I'll have it identify these holes. Recall it's pointing at our workpiece, so it's looking at the entire part, and we'll take any machining access direction. Okay, at first glance this appears very similar to the identification we've done in the past. However, I'm going to right click in a gray area here and choose Show Machining Areas. So let's look at one of these slots I made. Recall that we used PMI to assign the floor face, and now the PMI algorithm has identified with each one of these features the corresponding floor face and named it. You see the same behavior happening with the out-of-the-box holes. Although our slot is a fairly simple feature, as you get to more complex features, it's valuable to be able to identify by name these different parts of the feature. And so now with NX9 we have that capability with the customer created features as well. In a few minutes we'll explain how we can use that using the hole making commands. We'll look now at some of the new hole making commands in NX9 and see how they relate back to the geometry that we identified during the Machining Feature Navigator step. I'll go to Create Operation, and you can't find this in drilling. This is in the hole making area, and the new types here are the first 4. We're going to choose drilling for our example. I already have a drill created, and my first step is to define the geometry. I'll look at this 2 different ways. First, if I just select an edge, it does find the geometry for that edge, and it actually is then picking up the in-process workpiece to drill that hole. But let's look at what happens if we actually select the cylinder. Then I get a little different interface up here as it identifies the same faces that were found in the Machining Feature Navigator step. So now I have much more control over what I'm going to drill. In other words, do I want to just drill the counterbore, or do I want to drill all the way to the bottom of the hole? Because the navigator here identified those faces correctly, then I'm able to make decisions here in the drilling command. So I can do that here manually as I'm showing you, or this can be part of the programming that could be written into the Machining Knowledge Editor so that these kind of decisions could be made automatically. As we've worked on our teach feature and teach operation command, I've mentioned that these features are being saved. Let's look at where they are saved now. I'm here in the resource machining knowledge directory, and the files that I'm after are the machining knowledge.xml. Although this is a man-readable file, it's really not that useful. You need the machining knowledge editor. So here is the application open. It is a separate application. It's not found from within the NX environment. Let's look at a couple of the objects that are in here, specifically the ones that we've created. So I'm here in sample color feature. You'll recall that's where we saved the feature definition, and here are the 4 features that we created. Now let's go on to the machining knowledge, and here is one of the feature operation types that we created, the floor wall slot 1. Let's look briefly at the logic that was created automatically for us when we saved that operation. Remember that we did need to specify a tool that was in the library, and here is the complete specification for that tool so that other operations used in the future can then find that tool if it's not already in the NX file. You'll also see references to a less worked feature and a more worked feature. When NX is looking at how it's going to machine a feature that it's given, it thinks about it in a very similar way to how a machinist thinks of a feature. You basically think backwards. You look at the final tolerances for, say, the diameter and position of a hole. If a hole has a high diameter tolerance, you might decide to ream that hole. If it is a tight diameter and position, you might have to bore that hole. So that would be the last operation. Then backing up from that, you're going to drill a hole that's going to prepare you for either boring or reaming, and then backing up from that, you're going to either spot or center drill that hole. So looking at it the way NX does, the more worked feature is beginning with the bore. So for instance, that might be a 1-inch diameter hole that you're finishing with. The less worked feature is what the bore needs to see before it starts, and that might be, say, a 930 diameter hole, something like that. And then that is going to be created by a drill. So then the less worked feature that it requires is the center drill. So it's this constant trade-off between the more worked feature and the less worked feature that gets us from one operation to another. In this case, we do have a tool completely specified, but let's look at another way to do the U-shaped slot here. So here's an example of a slot that is not programmed in quite the same way. Here we are not specifying an exact tool. We're looking at the radius of the slot, and we're just making sure that we have a tool that will fit. So we're using the less than to have the machining knowledge editor determine a tool from the library that will work. It's looking at a couple things here. First, the flute length has to be greater than the depth of the more worked feature. And then the tool diameter has to be less than 2 times the radius that's found there in the more worked feature. So if those two criteria are met by the tool, then it can be used. So by adding just a little more logic to your operations here, you can get a lot more utility out of them. There certainly is many more things we could go through in the machining knowledge editor, but I'm hoping that that's a good overview of how we do feature-based machining in NX. Thank you.